Eugene Kooin and the Origin of Life. The origin of life is a very tough problem, and it has been getting tougher with time. In fact, if you go back far enough, the origin of life was not a problem. Originally, it was assumed that smaller creatures such as flies or rats arose spontaneously. That was the belief of such people as St. Thomas Aquinas, for example, or Augustine. The origin of life there was not a problem. Origin of higher life was a problem, but getting flies wasn't a big deal. You just put out some rotting meat, and sure enough, they appeared. It was known that larger creatures such as sheep, lions, people did not arise spontaneously, but the smaller creatures, and of course, rapidly, when bacteria were discovered, it was assumed that bacteria could arise spontaneously. By the time Darwin came around, it was starting to get sticky. Reedy had already destroyed the idea that flies arose from rotting meat. And Pasteur was in the process of doing the same for bacteria. And so when Darwin wrote his book, it's very interesting. He said from a few created forms, or perhaps one, that the whole thing came out, into being, almost explicitly agreeing to a divine creation. On the other hand, he didn't really like that, which is understandable from a non-interventionist perspective. That is to say, you don't want an interventionist God. And he talked about a warm little pond. So he kind of waffled on that question. However, if you're going to be a thoroughgoing atheist or materialist, not having anything outside of matter, you're going to have the spontaneous origin of life to have happened at least once. And that's especially true since we have the Big Bang and you can't just put it off forever. It was always there. In the meantime, life has been revealed not to be just a little clump of protoplasm, but all kinds of complex things are in there to keep life going. And they're apparently irreducibly complex. Now, if this was not challenged, it would produce a knockdown argument against materialism. Materialism requires the spontaneous origin of life. The spontaneous origin of life doesn't happen. Materialism is false. Very simple argument. Origin of life experiments trying to defuse this problem have not been able to use evolution at this point, because in order to have evolution, you have to have differential reproduction, the survival of the fitter. Differential reproduction requires reproduction. And so while in an evolutionary scenario, you can get from bacteria keeping the intermediate species alive to whatever you need to go to, in the origin of life, you can't keep the intermediates alive. Until they are actually alive, you're stuck with dead material that doesn't reproduce. So evolution doesn't help us here. In theory, the simplest reproduction of an information-containing molecule could have been an RNA molecule that could reproduce itself. And so the RNA world currently is the most popular theory of spontaneous generation. How likely is that? Well, we're about to ask Eugene Kooin. You say, who is Eugene Kooin? Well, he's a senior investigator at the National Center for Biotechnology Information, the National Library of Medicine, and the National Institutes of Health. Pretty well placed, I'd say. He's a Russian-American biologist, according to Wikipedia, recognized expert in the field of evolutionary and computational biology. So we're talking about somebody who really knows. And he wrote an article called The Cosmological Model of Eternal Inflation and the Transition from Chance to Biological Evolution in the History of Life, which is, in my opinion, and in many other people's opinion, a landmark article. It's a peer-reviewed article, as we will see. In fact, it's an open peer-reviewed article, so you can actually read what it has to say. And it's available on the internet, so it's free. You can look at this yourself. Now, I'm not going to give you the entire article. There will be omissions, and you'll see where they are. For the simple reason that we don't have time to read the whole thing, but I'm going to try to include the most important parts of it. The abstract, just to get you oriented, recent developments in cosmology radically changed the conception of the universe as well as the very notions of probable and possible. The model of eternal inflation implies that all macroscopic histories permitted by laws of physics are repeated an infinite number of times in the infinite multiverse. Wait a minute. Eugene Kooin is an authority on the multiverse as well. Well, at least he, I think, seems to be trying to follow the authorities. It's interesting that he is writing an article on the multiverse. In contrast to the traditional cosmological models of a single finite universe, this worldview provides for the origin of an infinite number of complex systems by chance, even as the probability of complexity emerging in any given region of the multiverse is extremely low. This change in perspective has profound implications for the history of any phenomenon, and life on Earth cannot be an exception. Hypothesis. Origin of life is a chicken and egg problem for biological evolution that is governed primarily by natural selection to take off. Efficient systems for replication and translation are required, but even bare-bones cores of these systems appear to be products of extensive selection. The currently favored partial solution is an RNA world without proteins in which replication is catalyzed by ribozymes and which serves as the cradle for the translation system. However, the RNA world faces its own hard problems as ribozyme-catalyzed RNA replication remains a hypothesis, and the selective pressures behind the origin of translation remain mysterious. Eternal inflation offers a viable alternative that is untenable in a finite universe. That is, a coupled system of translation and replication emerged by chance and became the breakthrough stage from which biological evolution, centered around Darwinian selection, took off. Basically, you can get a miracle out of it. A corollary of this hypothesis is that an RNA world as a diverse population of replicating RNA molecules might never have existed. In this model, the stage for Darwinian selection is set by anthropic selection of complex systems that rarely but inevitably emerge by chance in the infinite universe, multiverse. Conclusion, the plausibility of different models for the origin of life on Earth directly depend on the adopted cosmological scenario. In an infinite universe, multiverse, emergence of highly complex systems by chance is inevitable. Therefore, under this cosmology, an entity as complex as a coupled translation replication system should be considered a viable breakthrough stage for the onset of biological evolution. We don't need no stinking RNA world. We can just leapfrog that because all you need is the most infinitesimal of chances, and in an infinite number of universes, it will happen. Now, the next thing is reviewers. This article is reviewed by Eric Baptiste, David Krakauer, Sergei Maslov, and Itai and I. And it's open peer review, which I don't know why they included both at the same time, but it was kind of interesting, I thought. So the article is put up, the reviews are put up, the article is revised, and then is accepted for publication. But instead of this happening in some editor's quiet desk somewhere, it's happening where you can see who said what and why. So, evolution of the cosmos, eternal inflation, many worlds in one, and anthropic selection. The many worlds in one, hereafter MWO, model makes the startling prediction that all macroscopic, coarse-grained histories of events that are not forbidden by conservation laws of physics have realized or will realize. Now, as you read that, you go, wait a minute, have realized what? Well, actually, what they mean is have become real. So, if you want to think, have realized themselves, have realized somewhere in the infinite universe, and not just once, but an infinite number of times. There is, for example, an infinite number of macroscopically exact copies of the Earth with everything that exists on it, although the probability that a given observable region of the universe, hereafter O region, carries one of such copies is vanishingly tiny. This picture seems counterintuitive in the extreme. Somewhere there's another copy of you and me. Sounds weird. But is a direct consequence of eternal inflation, the dominant model of the evolution of the universe in modern cosmology. Why is inflation there in the first place? Inflation is an excellent agreement with several crucial results of observational cosmology. Above all, the flatness of space in our O region, the overall uniformity of the cosmic microwave background radiation, and its local non-homogeneities. Now let me back up a little bit and comment on that. Inflation was introduced because the universe is almost what they call flat, but not quite. And that requires a miracle to get out of a Big Bang, unless you take and stretch everything out to where it becomes almost flat. And that means that inflation was inserted as a physical principle to explain something that looked designed. Was inflation itself designed? That's an interesting question. Furthermore, the populated landscape version of string theory independently yields a very similar model of the multiverse. Well, is string theory true? That's a difficult question to answer at this point. Partly because string theory doesn't make enough predictions for us to be able to say it looks false or it looks true. Because string theory can predict anything if you adjust the variables appropriately. Thus, although the model of eternal inflation cannot be considered proved, this is the strongly preferred current scenario of cosmic evolution. So, we think we have inflation because otherwise it would take a God to make sure that everything came out as smooth as it is, as low entropy if you prefer. Now, Gergen Vilenkin show that in a finite time, the content of each O region can assume only a finite number of states, and accordingly any O region has a finite, even if unimaginably be vast, on the order of 10 to the 10 to the 150th power, number of unique macroscopic coarse-grained histories. That's because space can be divided into Planck spaces. And that means that the universe is digital, which we've heard in other contexts before. Effectively, the finiteness of the number of coarse-grained histories appears to be a straightforward corollary of quantum uncertainty. The same conclusion is independently reached through a completely different approach, namely the so-called holographic bound on the amount of entropy that can be contained in any finite region of the universe. The universe can be a hologram. Where have we heard of that before? From a slightly different perspective, the usual adage about the second law of thermodynamics being true in the statistical sense takes a literal meaning in an infinite universe. Any violation of this law that is permitted by other conservation laws will happen. Let that sink in. The second law of thermodynamics doesn't exist. It's not a law. It's just a probability factor going forward and not backwards. So we're going to follow all the laws of the universe except one, and that's the second law of thermodynamics.
What is that?
That entropy, which is a measure of disorder, is always increasing in the universe. It's the law that doesn't allow a tornado to sweep through a junk pile and build a house. Which is physically possible, but so entirely improbable that it never happens. So that law is being directly challenged. But I thought the second law had nothing to do with the spontaneous origin of life or with information creation. In order to get information creation, in order to get the second law of in order to get life, you have to defy the second law of thermodynamics. And this is one way of getting rid of that law.
Because they're sort of talking on both sides, aren't they? If it's going to happen an infinite number of times, it should be more obvious.
Yes,
I've already said it.
I know, but you're going to say more, too. For those, we're trying to catch all of this stuff on tape, and it's a little bit easier if we speak into the microphone, but I'm happy to have you make spontaneous comments. So, the spontaneous emergence of complex systems that would have to be considered virtually impossible in a finite universe becomes not only possible, but inevitable under many worlds. Even though the prior probabilities of the vast majority of histories to occur in a given O region are vanishingly small. This new power of chance, buttressed by anthropic selection, and we'll go on from there. The central problem, the emergence of biological evolution, the inherent paradoxes of the origin of replication. So he's given his solution, now he's going to give you the problem. The inherent paradoxes of the origin of replication and translation systems and the limitations of the RNA world. Now remember, this is the area of his expertise, not cosmology. The origins of replication and translation, hereafter in OORT, sometimes known as OOL, origin of life, is quantitatively different from other problems in evolutionary biology and might be viewed as the hardest problem in all of biology. Which I agree with. As soon as sufficiently fast and accurate genome replication emerges, biological evolution takes off. Well, except for problems like Darwin's doubt, but yeah, they're not as bad. I use this general term to include Darwinian natural selection, along with other major evolutionary mechanisms such as fixation of neutral mutations that provide material for subsequent adaptation, exaptation of spandrels, features that originally emerge as evolutionary byproducts, but are subsequently utilized for new functions, and duplications of genome regions followed by mutational and functional diversification. In other words, he's taken Darwinian evolution and all those other things that people add to it. All these processes that together comprise biological evolution become possible and actually inevitable once and only once efficient replications of the genetic material is established. He's convinced evolution works. But he says it doesn't work for the origin of life. The crucial question then is, how was the minimal complexity attained that is required to achieve the threshold replication fidelity? And even the simplest modern systems, such as RNA viruses with the replication fidelity of only 10 to the minus 3, that means if you have 1,000 nucleotides, one of them will probably be out of order. Replication is catalyzed by a complex protein replicase. Takes a really special protein to do it even that well. Even disregarding accessory subunits present in most replicases, the main catalytic subunit is a protein that consists of at least 300 amino acids. So it takes a big protein. The replicase, of course, is produced by translation of the respective mRNA, which is mediated by a tremendously complex molecular machinery. Hence the first paradox of OORT. To attain the minimal complexity required for a biological system to start on the path of biological evolution, a system of a far greater complexity, that is, a highly evolved one, appears to be required. This is, of course, my emphasis. How such a system could evolve is a puzzle that defeats conventional evolutionary thinking. Have you ever heard that we have almost solved the origin of life? Well, Eugene Kooin doesn't think so. The commonly considered solution is RNA world scenario, that is, the notion that replication evolved before translation, such that the earliest stage of life's evolution is a versatile community of replicating RNA molecules. A central element of the RNA world is a replicase consisting of RNA. The RNA world concept is supported by experimental discovery of diverse catalytic activities of ribozymes, catalytic RNAs, enzymes made up of RNA, which is why they're called ribozymes. However, all the advances of ribosymology notwithstanding, the prospects of a bona fide ribozyme replicase remain dim. That is, we have protein replicases. We do not, at this point, have ribozyme replicases. As the ribozymes designed for that purpose are capable, at best, of the addition of about 10 nucleotides to an oligonucleotide primer. They can only give you 10 nucleotides at a time. At a very slow rate, and with fidelity at least an order magnitude below that required for the replication of relatively long RNA molecules. In other words, they're not good, they're not fast, they're not accurate. And they can only do 10 at a time. It's worse than that. As recently noted by one of the leading RNA world explorers, despite valiant efforts, it appears unlikely that this particular polymerase enzyme will ever be evolved to the point that it can copy RNA molecules as long as itself. How long is it? 200 nucleotides. So the minimum appears to mean that we have to have over 200 nucleotides if we're going to have a decent RNA self-replicating molecule. Keep that number in mind. We're going to come back to it. Of course, it remains possible, and this is indeed the belief of the RNA world community, that other ribozymes are eventually evolved to that level. However, the evidence is lacking. If I can put it this way, ribozyme researchers are selling vaporware.
Well, it's faith. And so if they're going to insist that that's possible, then that's raising their faith to a religion. So, and they shouldn't be arrogant that their religion is better than other religions.
Yeah, I mean, I'm not going to deprive them of their religion. Maybe they'll turn out to be right. But it does seem that the jury should be open, at least. The second paradox of OORT pertains to the origin of the translation system from within the RNA world via a Darwinian evolutionary process. Now, see, the first thing is, how do you get it to replicate to begin with? And we've already said, we don't know if it's possible, but it looks like it's going to take over 200, right? And actually, if you think about it, that means it takes over 400. Because in order to get the process started, it's not enough to have a ribozyme. You have to have 2 copies of the ribozyme, one to do the copying and the other one to be copied. Until you have both copies, you can't get anywhere. The second paradox pertains to, now that we've gotten all this copying RNA and it's making itself and everything, we've got to get from RNA to something that does protein. And here we get into the origin of the translation system from within the RNA world via the translation into protein system from within the RNA world via Darwinian evolutionary process. Until the translation system produces functional proteins, there is no obvious selective advantage to the evolution of any parts for this elaborate, even its most primitive form, molecular machine. Have you ever heard that kind of argument before? Sounds suspiciously like what Michael Behe would say, right? This is irreducible complexity. Keep that in mind, because we're going to run into that again. Conceptually, this paradox is closely related to the general problem of the evolution of complex systems that was first recognized by Darwin in his famous discussion of the evolution of the eye. Yes. Yes. The solution sketched by Darwin centered around the evolutionary refinement of a primitive version of the function of the complex organ, where each modification was of a little more advantage. Subsequently, the importance of the exaptation route for the evolution of complex systems has been realized. Exaptation meaning you developed one part for this function and another part for that function, and you know what? They fit together really nicely and do their own thing. However, origin of translation resists both lines of reasoning. They don't work. This is irreducibly complex. Primitive translation in a protein-free system is conceivable as an intermediate stage of evolution. See below. But this does not resolve the paradox, because even for that form of translation to function, the core components must have been in place already. Speculative scenarios have been developed on the basis of the idea that even short peptides could provide selective advantage to an evolving system in the RNA world by stabilizing RNA molecules. Okay, so you don't have to have full proteins yet. All you have to do is just translate reliably, accurately, 5, 6, 10 amino acids together, affecting their conformations or enhancing their catalytic activities. And has a discussion that he refers you to. These ideas are compatible with observed effect of peptides on ribozyme activity. But none of the scenarios is complete or supported by any specific evidence, and all include reactions without precedent in modern biological or model systems. Again, you are being sold vaporware. All this is not to suggest that OORT is a problem of irreducible complexity. Really? and that the systems of replication and translation could not emerge by means of biological evolution. It remains possible that a compelling evolutionary scenario is eventually developed and perhaps validated experimentally. Well, it doesn't prove it, I would agree, but suggest it? Come on. However, it is clear that OORT is not just the hardest problem in all of evolutionary biology, but one that is quantitatively distinct from the rest. For all the other problems, the basis of biological evolution, genomic replication, is in place. But in the case of OORT, the emergence of this mechanism itself is the explanandum, the thing to be explained. Thus, it is of interest to consider radically different scenarios for OORT. So he's saying, we don't have a clue, we're going to have to look in a different direction. The transition from anthropic selection to biological evolution in the history of life and the no RNA world scenario. The history of life includes a crucial transition from chance to biological evolution. Figure 1. Biological evolution cannot take off before there are polymers, most likely RNA molecules, and means for their sustainable replication. Thus, the synthesis of nucleotides, and at least moderate-sized polynucleotides, could not have evolved biologically and must have emerged abiogenically, that is, effectively, by chance, abetted by chemical selection. That is, for example, preferential survival of stable RNA species. At the other end of the spectrum, there can be no reasonable doubt that the first cells were brought about by biological evolution. Why no reasonable doubt? Because we've ruled out design. Somewhere in between is the transition, the threshold of biological evolution. Most often, since the advent of the RNA world concept, this threshold is implicitly linked to the emergence of replicating RNA molecules. Translation is thought to have evolved later via an unspecified, or at best invented, ad hoc selective process. As discussed in the preceding section, both the ribozyme-catalyzed replication and especially evolution of translation in the RNA world faces formidable difficulties. The MWO model dramatically expands the interval on the axis of organizational complexity, where the threshold can belong, by making emergence of complexity attainable by chance. In this framework, the possibility that the breakthrough stage from the onset of biological evolution was a high complexity state, that is, that the core of the coupled system of translation replication emerged by chance, cannot be dismissed, however unlikely. That is extremely rare in the multiverse. It's because everything that can happen will happen. The modern translation apparatus shows clear signs of evolution by duplication and diversification in the essential ubiquitous components, allowing one to glean some features of the putative breakthrough system. Analysis of the duplications in the key proteins involved in translation suggests that the breakthrough system was an RNA-based machine, to much greater extent than the modern translation system. Specifically, the aminoacyl TRA synthetases comprise two unrelated classes, each of which evolved by a series of duplications. Moreover, both classes of paralogous AARS are relatively late elaborations within large classes of nucleotidases, strongly suggesting that the breakthrough system activated amino acids via an RNA-only mechanism. The same pertains to the translation factors that are relatively late products of evolution within the GTPase class of the P-loop NTPases. Thus, the breakthrough system would not employ protein translation factors. The breakthrough system is all RNA, according to this. The phenomenon of mimicking tRNA structures by some of the translation factors further support the notion that the ancestral translation system was RNA-centered. The experimentally demonstrated activities of ribozymes include, among others, those that are involved in the main chemical steps of translation, such as amino acid activation, RNA amino acylation. In other words, these things can be done by ribozymes, and peptidyl transfer. Self-amino acylation of ribozymes selected for this activity is rapid and highly accurate, remarkably, even more so than the same reaction catalyzed by the cognate AARS. Perhaps most importantly, the large subunit rRNA is itself a ribozyme that catalyzes a peptidyl transferase reaction. Thus, an RNA-only translation system, although so far not demonstrated experimentally, appears to be a realistic possibility. Well, a lot of general stuff is being thrown in, and without a lot of specifics. But, you know, you can kind of see where they're going. Maybe it will work. A notable and enigmatic feature of the modern translation machinery is the common structure and presence of conserved sequence elements in the tRNAs of all specificities, which suggests that all tRNAs are ancient paralogs. Thus, the current set of tRNAs obviously is a product of biological evolution. This is called blinders. And let me explain. If you have a tRNA, transfer RNA, it needs an amino acid on one end, and it needs a triple codon on the other end so that it can function, and it needs to fit within the machine. And the rest of it needs to look pretty close to identical, so that the only difference is the triple at the bottom and the amino acid at the top. Right? Otherwise, the machine has to be made with a lot of slop. So it's not really a big surprise that you have tRNAs that have triple amino acid at the bottom, triple codon at the bottom, and an amino acid containing thing stuck to the top, and otherwise they look virtually identical, because that's what the design requires. Even if you don't believe there's a designer, you can't make the machine work unless those things are pretty close to identical, which suggests that their sequence should be pretty close to identical. And so the fact that they all have more or less the same sequence is kind of required by their function.
And you have to have this for every kind of amino acid.
Right. Obviously a product of biological evolution. If there were a designer, you would expect them to be identical also, or close to identical. Think about it. How can you say, well, it must be evolution, because chances of getting it without evolution are just too low? But of course, we're getting ready to propose the multiverse, so why are those chances too low again? Under the present model, the core elements of translation system, namely an RNA-only ribosome and the specific adapters for at least a subset of the 20 modern protein amino acids, emerged by chance and were anthropically selected. The breakthrough system was a primitive RNA-based translation machine that was capable of translating exogenous RNAs such that functional proteins, including a replicase, could be generated. The presence of a diversity of randomly synthesized RNAs, including one that encoded a protein with a replicase activity, however low initially, on the early Earth, would be another anthropically selected feature. What are we talking about by anthropic selection? What we're talking about is, if they weren't that good, they would never have gotten to us, and so we wouldn't see them. So the fact that we see them means that they were selected so that we could see them. Now that's kind of a cross between the weak and the strong. The weak anthropic principle just says that the universe must be good enough for us to be here. We don't exist in the middle of the sun because we would all be destroyed and never realize that we were here to begin with. So we have to live on a temperate planet. It can't be too hot, can't be too cold, and so forth. Well, we have to live on a planet where certain things happened. Otherwise, we wouldn't be here either. The strong one says the universe needs observers and therefore it's going to make them sooner or later, which is an almost religious proposition. For such an ensemble of RNA molecules to exist, a natural reactor is required in which polynucleotides are produced at an adequate rate and chemical selection occurs such that stable molecules survive longer. Wait a minute. I think that that's a duplicate slide for some reason. The modern universal genetic code is much more robust than expected by chance with respect to mutational and probably also translational errors. It has been estimated that the probability to obtain a code within the same or greater robustness than the actual one is 10 to the minus sixth. 1 in a million. Remember hearing about that in our book, Biological Information, New Perspectives? Yeah. That's recognized by everybody, including Eugene Kooin. This is typically considered to be a result of evolutionary optimization of the code, but as we saw, the evolutionary optimization becomes very, very difficult. You have to invent a whole bunch of different codes, and then you have to select the best one. However, the many worlds model suggests an alternative view under which the basic structure of the code results from anthropic selection. Objections, implications, and falsification. The present proposal, the appearance via anthropic selection alone of an RNA protein system sufficiently complex to couple translation replication, such that biological evolution could take off, might seem quite outrageous. Well, yeah. However, there are several mitigating considerations. First, the postulated chance origin of the replication translation system does not require any mysterious processes. Oh, good, like design. Second, any conceivable scenario of life's evolution necessarily requires combinations of highly unlikely conditions and events prior to the onset of biological evolution. In other words, nobody's got any better ideas. Thus, anthropic selection appears to be an inevitable aspect of life's evolution. That is to say, we need chance beyond what you can expect in a single universe, so there must have been multiple ones. A crucial aspect of the framework developed here is brought about by a disturbing, almost nightmarish, but inevitable question. In the infinitely redundant world of many worlds, why is biological evolution, and in particular Darwinian selection, relevant at all? Is it not possible for any, even the highest degree of complexity, to emerge by chance? The answer is yes. But the question misses the point. Under the MWO model, emergence of an infinite number of complex biotas by chance is inevitable, but these would be vastly less common than those that evolved by the scenario that included the switch from chance anthropic selection to biological evolution. So, if you have less to explain, you just assume that it probably came about by chance following evolution rather than chance plain, because chance plain is just even more unlikely. Thus, in any reconstruction of the origin of life, the threshold should be mapped to the lowest possible point, to the minimally complex system capable of biological evolution. Sorry. No. That's what happens when you... We'll get there. Here we go. The strong form of the present hypothesis, that is, the notion that the breakthrough stage in the history of life is a primitive coupled replication translation system, is falsifiable. How is it falsifiable? Well, such a system should be construed as the upper bound of complexity for the breakthrough stage. As soon as the possibility of biological evolution at a lower level of complexity, that is, for example, in the RNA world, is demonstrated and the route from the RNA world to the translation system is established, either experimentally or at least in a compelling model, the origin of a complex system with coupled replication and translation by chance anthropic selection will be effectively ruled out. In other words, we don't need to jump all the way if we can jump halfway and then evolve the rest. So then the jump all the way would be falsified. A demonstration that life independently emerged on several planets in our O region will have the same effect. Or will it? Because in some universe, it originated spontaneously on all worlds. In the appendix, and we're going to come back to that because that's the juiciest part of this whole paper, I present such calculations for two versions, the RNA world with a ribozyme replicase and the coupled translation replication system. Those two steps he talked about before. An unrealistically high rate of abiogenic RNA production is assumed, as we will see. However, any significant increase in complexity would call for a different cosmological model. In particular, the emergence of a coupled replication translation system is unlikely to the extent of being effectively impossible.
At last, that word, impossible.
For such a complex system to be a viable candidate for the breakthrough stage, an infinite multiverse such as the one depicted by MWO, or in the very least a universe with a vast number of O regions, is indeed a must. The many worlds is to get around impossible. Of course, the most straightforward and powerful falsification would be to disprove the MWO itself. Here, however, an important disclaimer is due. It is not actually crucial for the validity of the conceptual framework presented here that MWO is correct in all its details. Only two rather generic assumptions are essential. A spatially infinite universe such as any island universe in MWO, the multiverse, while integral to eternal inflation, is not actually required for my argument. In other words, you don't have to have a spatially infinite universe. The finiteness of the number of macroscopic history in any finite region of space time. Basically, you have to have the universe be able to be digitized, which is, probably fair. The strong form of the hypothesis presented here will not be falsified if some specific details of the MWO turns out to be wrong, but only if one of these general assumptions fails. You have to have lots of universes, and the universe has to be digitized. Conclusion. Despite considerable experimental and theoretical effort, no compelling scenarios currently exist for the origin of replication and translation. The origin of life is not solved. It is not close to solved. The key process that together comprise the core of biological systems and the apparent prerequisites of biological evolution. The RNA world concept might offer the best chance for the resolution of this conundrum, but so far cannot adequately account for the emergence of an efficient RNA replicase or the translation system. The MWO version of the cosmological model of eternal inflation could suggest a way out of this conundrum. This dramatically expands the interval on the scale of organizational complexity where the transition from anthropic selection to biological evolution might belong. Specifically, it becomes conceivable that the minimal requirement, the breakthrough stage, for the onset of biological evolution is a primitive coupled replication translation system that emerged by chance straight into that primitive couple, in other words, skipping the RNA world entirely. However, this does not defy the central role of RNA in the emergence of biological evolution and early evolution of life. In other words, it still might be mostly RNA to begin with, but you got to jump into the translation system whole. And to do that, you need many worlds. I finally comment on irreducible complexity in intelligent design. Some of you go, whoa. By showing that highly complex systems actually can emerge by chance, and moreover are inevitable. If extremely rare in the universe, the present model sidesteps the issue of irreducibility and leaves no room whatsoever for any form of intelligent design.
Didn't show it. I don't want it, so it's not there. Showing. I didn't see it.
What it is, it's an attempt to get around the obvious impression of design and the fact that there is no good hypothesis for the origin of life. So we'll just use many worlds, which means the chance doesn't mean anything. Now, the appendix, like I say, is even more fun. Probabilities for the emergence by chance of different versions of the breakthrough system in an O region, a toy calculation of the upper bounds. This is the upper bounds, and this is a hopelessly optimistic calculation of the upper bounds. General assumptions. An O region contains 10 to the 22 stars, and every 10th star has a habitable planet, hence 10 to the 21 habitable planets. Undoubtedly a gross overestimation, because in reality most stars have no planets at all, let alone habitable ones. Okay, so we're already, these are rose-tinted glasses. A volume of 5 times 10 centimeters is available for RNA synthesis, undoubtedly an gross overestimation, because in reality there would be very few RNA-making reactors. So, okay. Let the concentration of nucleotides in volume V and the rate of the synthesis of RNA molecules of size n be 1 molecule per centimeter per second, a gross overestimate for any sizable molecule. So we're overestimating left and right. Then the number of unique N-mers tried out during the time after the Big Bang is 1.5 times 10 to the 61 when you get done with all the numbers. Let us assume that for the onset of biological evolution, a unique N-mer is required. We don't know that, but it's a reasonable assumption. The number of such sequences n is 4 to the n is 10 to the 0.6 n, which is standard math. Then the expectation of the origin of number of times of unique N-mers emerging in an O region is this expression, 10 to the 1.5 to the times 10 to the 61 divided by 10 to the 0.6 n. And if you solve for n, you get n equals log e times and so forth. Now, substituting e for 1, you expect to get 1. We get n equals 102 nucleotides. Note that n is, because n is proportional to log s, the estimate is highly robust to the assumptions on the values of the contributing variables. For example, an order of magnitude change in s will result in an increase and decrease of n by less than 2 nucleotides. This is log, so they don't move very much. Now, a ribozyme replicase consisting of around 100 nucleotides is conceivable, so in principle, spontaneous origin of such an entity in a finite universe consisting of a single O region cannot be ruled out in this toy model. Again, the rate of RNA synthesis is considered here as a deliberate gross overestimate. Wait a minute. Okay, not only are we inflating the numbers, anybody remember how many nucleotides it takes to put 10? 200. Minimum. What happens if you plug those in? Well, we'll get to that at the end. Let's just say that the numbers are quite a bit smaller. The requirements for the emergence of a primitive coupled replication translation system, which is considered a candidate for the breakthrough stage in this paper, are much greater. At a minimum, spontaneous formation of 2 RNAs with a total size of at least 1,000 nucleotides. 10 primitive adapters of 30, we're going bare bones here. 30 nucleotides each with a total of 300 nucleotides. Remember, this is all vaporware. This is all selling things at the lowest possible level. and probably below the lowest possible level. At least one RNA encoding a replicase. 500 nucleotides, lower bound is required. In the above notation, n equals 1800, resulting in E is less than 10 to the minus 1018, 1000, E to the 10 to 1000. The probability of getting this kind of thing with the most wildly inflated, hoped for projections is to 10 to the minus 1000. In other words, even in this toy model that assumes a deliberately inflated RNA production, the probability that a coupled translation replication emerges by chance in a single O region is P is less than 10 to the minus 1018. Obviously, this version of the breakthrough stage can be considered only in the context of a universe with an infinite, or in the very least, extremely vast number of O regions. Question?
And the number of particles in this entire universe?
The number of particles in the entire universe
10
is
to the power of 80.
10 to the 80th, more or less. Yes. Yes. The model considered here is not supposed to be realistic by any account. It only serves to illustrate the difference in the demands on chance for the origin of different versions of the breakthrough system, and hence the connections between these versions and different cosmological models of the universe.
Is this Kooin speaking or is this
This
Giem?
is Kooin.
This is Kooin speaking. Thank you.
Yes. I am quoting. Okay, reviews. And I'm not going to read the whole thing, obviously. In this review, I will simply try to rephrase what serious problem Kooin has identified according to me, and I will argue that I am afraid his answer to this problem might open too broad an avenue to the supporters of intelligent design, as it is currently formulated, and thus does not satisfy me as such for an alternative to the theory of the RNA world. This is too close to ID. Kooin bravely tries to tackle such a deep conceptual issue using metaphysics where, according to him, science does not seem to work. But I am afraid his present and arguable solution, although fairly underlying one of the limits of traditional evolutionary thinking, in other words, he's right about the problem, could open a huge door to the tenets of intelligent design. Forgive the spelling, Baptiste is French. Unfortunately, as long as he does not carefully introduce and clarify his anthropic selection principle, I think that he might be unwillingly opening a huge door to ID supporters to enter into the very heart of evolution, of the evolutionary theory. Worse, again, there's actually, I'm probably reading about 1/8 of what he had to say, but it's a significant proportion of it. What guarantee do we have that there won't be ID people to claim that, as the very important evolutionary biologist E. Kooin showed, as we are doing right here, Darwinian selection is a secondary player in cosmology and is itself a force evolved for a reason, a chosen byproduct of anthropic selection, in which case everything evolving under Darwinian selection evolves in fact under the eternal drive of the anthropic principle. For all these questions could be exploited very meanly by the ID people. Kooin is, in my view, very naive to think that he can call in teleology to start the process of evolution and call it off subsequently. If teleology is called in, a divine foot in the door, can we say? If teleology is called in, a view which I doubt is worth supporting in science and I feel is dangerous, unless teleology achieves the goal that is needed for, there's no reason why teleology should suddenly stop being relevant in the middle of the way. And this is Eugene Koonin's answer. The possibility that the ID crowd interprets this paper as support for their cause is one of Baptiste's main concerns. Will they actually? No doubt they will. However, the only way to prevent them from doing so is to stop publishing research on any hard problem in evolutionary biology and some how declare these problems solved. Have you ever heard that proposed as a there are no problems with evolutionary biology, and we shouldn't teach any problems with evolutionary biology because there aren't any? Yes. The ID folks do no research themselves, well, except for Douglas Axe, who's done similar research like this. But so they apply all their considerable intellectual resources to turn public scientific work upside down and claim support for ID. It happened to several seemingly innocuous papers of mine, to my considerable amusement. I believe evolutionary biologists should not, and actually cannot, worry about this, only about their own papers being correct and coherent. Yes! And I'm skipping 2 and 3. By the way, none of them objected to his toy calculations. In fact, one of them, and I forgot to put it in, actually thanked him for doing them, to give people an idea of what it was like. Reviewer 4 of Harvard University. The context of this article is framed by the current lack of a complete and plausible scenario for the origin of life. The front-runner model, that of the RNA world, that's the front-runner model. There have been other models for the origin of life, but despite much ingenuity and effort, it is fair to say that all origin of life models suffer from astoundingly low probabilities of actually occurring. Is that not working or something?
Yes. There we go.
Go ahead.
That if you're approaching this not from a religious standpoint, as an evolutionist, it doesn't matter. It shouldn't matter what, you're just studying it to study it for its own sake, and you're not coming at it from an a priori position. So, but if you are coming at it from a priori position, then it does matter what other people of other philosophies think. I don't know, am I being clear here? So they're coming at it from a religious standpoint themselves.
Yeah, no, that's very definitely true. My opinion is that Kooin is overly optimistic. Of course, he recognizes this, but there are other sources of excess optimism, and one of them that we mentioned, but a couple of that we haven't. RNA monomers are not that easy to form. They require ribose, they require a base, they require sticking them together somehow, or creating them both at the same time, which is an even more fun proposition. Without enzymes, this is really tough. The original replicator may not exist or may require hundreds of RNA monomers to work. Certainly the ones we have that suggest that there are probably 200 or more, and there need to be 2 replicators at the beginning, and so minimum length of a replicator that we know of anyway is around 200 rather than 100, and now we're going to recalculate. And when you crank the numbers, you get the expected number of per universe is 1.5 times 10 to the minus 179, which is not quite 10 to the 1,000th, but it's up there. It's certainly not what you'd want to bet your horse racing money on.
In statistics, is there a concept of something being impossible if it's at a certain level of improbability? Isn't there a number, 10 to the minus 50 or something?
Well, yeah, Borel's number is 10 to the minus 50, and Richard Dawkins would accept that, interestingly enough, except when it goes against his own hypothesis, in which case he just tosses it out. Dembski's number is 10 to the minus 150. Well, this is beyond that. This is just getting the RNA replicator itself. This is not getting the whole system. The whole system is still another 1,000 beyond that. And that's assuming that once you get started on the RNA world, you start growing all kinds of crazy RNA. I think Kunis is honest. He's honest about the problem. He's honest about his antipathy to intelligent design. And he's honest about the need for science to ignore concerns about ID. And for that, I applaud him, and it's one of the reasons why I'm presenting his paper.
How did he expect us to ignore those concerns? He's trying to persuade his fellow scientists to ignore the reality of God.
Well, you see, the fellow scientists, I think, the ones that he's talking to are kind of happy with the idea of ignoring God. And the kinds of things he's presenting would be very, very uncomfortable if he didn't have a way out. See, that's what the multiverse does for him. It's an escape clause.
So he's insisting on a self-imposed blindness, a refusal to consider this other reality, this other possibility.
An almost religious opposition.
Well, whatever you may define as religious. I would like to comment here. About a month ago, Paul, there was an article published in New Scientist magazine which caught my eye, and I'm sorry I didn't bring it here. But its title, and now this is in New Scientist, the title was Multiverse, Get Real. And now that was a publication and a title of an article in a well-recognized magazine. So I'm at least relieved to know that there are some authors who are willing to admit that the multiverse is not a realistic expectation.
Well, yeah, but see, Kooin needs a multiverse, so he's quite happy to have it now.
Yes.
Now, let's go on. Others are perhaps a little bit less honest. And let me give you the example. Alan Musgrave, I hope he has moved beyond that, but we will see. In Talk Origins, wrote something on if you're the abioprob, that's a abiogenesis problem. And in his article, he said, he listed a whole bunch of errors that people who are trying to do calculations on the origin of life make. And he said, I will try to walk people through these various errors and show why it is not possible to do a probability of abiogenesis calculation in any meaningful way. Now, note, not that the calculations are wrong, and here's how to do them right. But you can't even do them. Why not? Because if you do, you get Eugene Koonin's answer. I think Koonin is substantially right about the seriousness of the problem and about the alternatives. It's God or the multiverse.
Who are you quoting here? Is this you?
Oh, this is Alan Musgrave of Talk Origins. So this is what they feed people who come and want to ask questions. When you get into the actual papers where Koonin says, I got to tell it like it is, he tells it like it is. It ain't pretty. And without the multiverse, you're hung.
Well, let's get
Anyway, that's my opinion. Now I'm going to turn it over to you guys. Mickey.
Well, let's give them the multiverse. I mean, so if you really believe in it, then and if all possibilities are eventually occur, then the one that has an intelligent designer in it will occur too. So if you're going to really believe in the multiverse, then how could you say that some possibilities won't happen?
Because they're not allowed by the laws of physics. But see, this
But
gets
we're saying
sticky.
in a multiverse that the same laws of physics apply in every multiverse?
All except the second law.
Yeah, see? So there you go. So it's the same.
Now, think about this. What it means is, if you go that route, you have no defense, no scientific defense against a reliable historical record. Because if you say that couldn't have happened scientifically, and your scientific arguments include the second law, then in some universe it did happen. In which case, if we have reliable witnesses that say it happened, ours must be that universe. So the origin of life is impossible. Well, statistically impossible. But statistics are out the window. If we have reliable witnesses that say it happened, then it happened. But it doesn't stop there, as the first reviewer was worried about. And as I don't think Eugene Kooin was not sufficiently worried about. Because what happens now if you have reliable witnesses that say somebody was walking on water? Well, see, all it takes to walk on water is to have 50.0001% of the water molecules going up instead of down. Creates pressure enough under your feet where it'll support your weight. Now, that doesn't happen in a world in which the second law is firmly entrenched. But if the second law doesn't count, then there is nothing at all to prevent you from being able to walk on water. So if we have reliable witnesses saying they saw somebody walk on water, there's no scientific defense against it. I'm not sure that's where they wanted to go.
I think one can always go to the improbability argument and admit, or have to admit, that it is possible. All multiverses, and people are talking about, maybe the universe has existed forever and so on, that it could have possibly happened. But this argument today and so on is a rather restricted view. And let me just tell you an incident that happened here many years ago. I was invited by the geology department at the University of California, Riverside, to give an article, give a paper, a seminar on why I believe in creation. I'd taken courses there, and they knew me and so on. And biggest seminar of the year they had there in the big auditorium. And one of the arguments I presented was the improbability of the origin of life. And didn't have these Kooin's figures at all. But I did mention 10 to the minus 78 as a probability, and the figures were already out there.
Yeah.
But the interesting thing, I think the important thing for us here is that as soon as I quit, first question that came from the students was, he said, "You have told us how improbable it is that life can arrange by itself, how evolution has a problem and so on. What I want to know is, what is the probability that God exists?"
That's next week.
In doing that, and I thank God that he gave me the answer. In doing that, he changed the whole realm of discussion from, hey, what Kooin is saying, life is probable anyway, that's Kooin's argument here. Changed it from, hey, which is more probable? Because I'd said, how improbable it is that life could arise. He said, hey, what's the probability God exists? And I simply told him, well, all these ratios I've given you here of improbabilities, I say, the probability God exists, either there is a God or there isn't a God. Which one are you going to pick? Well, I said, you just reverse those ratios. This is the ratio that God exists,
The probability is 10 to the 7, 1 minus 10 to the minus 78.
Exactly.
Or whatever it is.
We must be trapped by the narrow pattern that this discussion puts us into, in a certain extent. What about the total picture here? Is there a God or isn't there a God? It comes out, hey, it's on the side of God, very definitely, tremendously on the side of God.
Yeah. It depends on how you want to construct this, but these are, as he said, toy calculations. If you apply more realistic calculations, the numbers are even worse. Once you get beyond 10 to the minus 300, give it up. And, at some point you just simply say, it makes way more sense for there to be a God than for there not to be.
Exactly.
And that's kind of where I come down. I'm an open-minded fella. You can, I'll be willing to walk with you in the atheist pathway. Just there's this big pile of junk in front of the door. You dig through that junk, and once you do, I'll go with you.
You can make, I think, a sound argument that the broader your question is, the more likely you're allowed to find truth, comparing to limited to a very narrow question.
Well, we come back to that next week. It's called prior probabilities. Because that's where the whole answer is. And once you realize that this is not a fight between science and religion. This is a fight between religion and science. They've been completely mislabeled. And that's a fight I'm willing to have.
So, okay, I guess it's on. So what was he in support? Was he supporting the idea that if they discover life on another world, then that proves that an evolutionary process is correct? I mean, if we discover life on another world, does that support their position? Is he making that claim?
I don't think he thought through that sentence very well. Because if we find life on another world, then you have to go back to, are those calculations valid?
We already said they weren't.
Well, but he said they weren't he said they were at least valid. That this is the maximum you can get out.
That's the worst case scenario, or the
No,
best
that's
case?
the best case scenario is 10 to the minus 1,018.
Okay.
And as I pointed out, he already slopped on RNA reproducing itself.
But then they are looking for another scenario, and finding life on another world would support them saying, this discussion, this type of model is incorrect. Obviously, life does form on its own at other places.
No, it doesn't. He might argue that way, and I don't know whether he would or not, so I don't want to put words into his mouth. But I think that one could argue at that point that now we have multiplied the probabilities, and one of two things happens. Either you just say, well, in a multiverse anything can happen, in which case science is pretty much out of the window. Or you could say, maybe there's a designer that did it both places. But you see, you can't get to, well, then there must be another pathway unless you know that there isn't another different kind of pathway, unless you know that intelligent design is wrong to begin with.
But discovery of life on another world would imply that there is a pathway that's more probable than we understand.
But it wouldn't imply a pathway without an intelligent designer. Unless you start out knowing that there was an intelligent designer to begin with. then you could say, well, it must be easier than we thought.
Kooin is saying that it's multiverse.
Yeah.
It's improbable, but boy, it had to happen.
It had to happen, so we basically play the lottery millions of times, and sooner or later we're going to win.
Well, I just bring this up because there's a really good chance we have the technology now to look for life on other worlds. And there may be in the next 10 to 20 years an announcement that they have discovered a life on another world. So what kind of argument, I mean, obviously there's so much effort being put into looking for life on other worlds because there's an advantage to doing that. They wouldn't do it if there wasn't something that would answer or give them support in their in their model of the universe. So obviously, if they do discover life on another world, and we could hear an announcement anytime, and it could be in the next 10 or 20 years.
And I will have to say that be careful because half the announcements are going to be frauds.
But, not
to negate your point, but announcement doesn't mean that it actually happened, as we have found out a number of times. Arsenic life, perfectly Earth-like planet.
Well, all they have to do is
Yeah,
discover spectral features that are signatures of life.
And I agree with you. I agree with you. That might happen.
They'll have a justifiable reason for claiming that there's life on this world. And all they have to do is find oxygen in significant amounts in the atmosphere of another planet. Then they have the position to say that there's life on that planet because we have no other understanding of how extensive amounts of oxygen could be produced in a planet without life.
But don't they then have to devise a pathway for producing life on another planet?
Well, see,
but
it depends. It depends on what your original assumptions are, and this is really critical. If you start out by assuming that there cannot be a God, and then we find life here, which is really difficult to explain, but we find life somewhere else, then we must just be missing something. There must be a simple pathway. There has to be, because it happened twice.
Yeah.
It can't be just we won the lucky lottery. Although then again, if you've got a multiverse, why can't we win the lucky lottery 5 times, 20 times? Once you get the multiverse in there, you can do anything.
But you're going to hear, that basically that evolution is one.
You're going to hear that evolution is one, and it's going to be a total spin, because the only way evolution wins is if it starts out by winning.
Let me remind you.
If it actually has to win instead of to win by default, it can't win.
Let me remind you that cosmologists are very resourceful people. And when they found meteorites from Mars, hey, they found life on it and so on. This is all kind of been
yes.
It doesn't take long for them to think, hey, life can transfer from one planet to the other.
Sure. But
I give them 1 day to do it.
Yeah. Well, first of all, that turned out not to be quite as good as it looked like. Secondly, even if we found Earth-like life on Mars, one would have to be assured that it came from Mars to Earth instead of from Earth to Mars. I mean, there was the Choluxicab meteorite that hit near Mexico and shot stuff all over, some of which may have reached escape velocities and drifted off towards the red planet and taken a chunk of algae with it.
That would be contamination.
Well, it would be life going from Earth to Mars, right? So the problem with a planet on another star is it's difficult to envision Choluxicab sending it all the way to Arcturus.
Francis Crick would say it's not impossible. Panspermia.
Well, as a matter of fact, one of the possibilities that has been raised is that the universe started out a very tight ball, And as it expanded, there came a point where the universe was cool enough all over so that the entire universe became an origin of life scenario, and that all the life came from there.
Somebody over there.
Let's get you into the conversation here. Sorry.
Can you go back to the Appendix A where he actually did that calculation of he had the number of planets and then the number of proteins?
I'll see what I can do.
You had it up there on the slide where he multiplied the 10 to the 22nd times the 10 to the 21st times.
Let's see. That would be up about here. There. Okay. So, let's see.
Yeah, I think it's the next
It was
one.
this one right here.
Okay,
Yeah.
so his assumption is that there's 10 to the 22nd stars, and then every 10th planet, or every 10th stars has a habitable planet, so 10 to the 21. So I'm a little confused about its calculation and then the argument that you're having here with how many planets does what. Because it seems to me like he's arguing that the number of planets in the universe decreases the probability of the life originating. So if there's only one planet, then the probability is higher.
No. He's making the exact reverse argument. He's saying that if there are lots of planets on which it could evolve, then something that was a probability 10 to the minus 21 is going to happen on one of them.
Right. Okay, so go to the next slide.
Okay. And this says that every habitable planet is
times
making
volume.
RNA, which again is a gross estimate for any sizable molecule, as he puts it.
Yeah, there was, I guess it might be even the next slide after this where he makes the calculation, the n-mers, right there, okay. So he's taking 10 to the 22nd times 10 to the 21st. So what happens if that 10 to the 21st becomes lesser planets? Like,
well, no, this 10 to the 21st is the planets.
Right.
If you go back here, you will see there's a volume of 5 times 10 to the centimeter, and they're doing 1 molecule per second, and so there's 10 to the 20 minus 21 seconds. So, he isn't showing all of his work.
Right,
but
right.
the 10 to the 21 is coming from somewhere other than the 10 to the 22nd.
yeah. So if we substitute in 10 to the 21st number of planets for just our own planet, assuming that, like other people, that then it doesn't exist, there's no extra life on other planets, then that calculation drops significantly.
Yeah.
It's only 10 to the 22nd times 3 times 10
That's
to the
right.
17.
That's right.
So
That's right. If ours is the only habitable planet in the universe, then you drop by a factor of 10 to the minus 21 right off the bat.
Right. So if they observe life on a second planet, then you put 2 in there instead of 1. The probability, it seems like...
It actually gets stickier than that, because not only is it 10 to the minus... We are highly unlikely to detect a planet in any other galaxy than our own. So now we're not only talking about the universe, but we're talking about our own local area. And so the probabilities now have to go way up.
But these are probabilities based on purely random assumptions. If there's, it doesn't take into account any kind of correlations that once for example, a single galaxy has the right conditions, then for its ability to create stars with habitable zones, then it may be that once that galaxy has certain properties, then it's not a random process from then on to create stars with habitable zones. It's a process that would naturally occur, and thus not be random, and it's correlated. So
No, here's the thing. He's making an assumption about habitable zones that's arguably, in fact, let's supposing that every single star has a habitable planet on it. You increase the chances by 10.
10, yeah.
10 to the 1. If you take every single star and put 10 habitable planets around it, you increase it by 100, 10 to the 2. Those are insignificant numbers compared with the numbers we're talking about. You can't go any higher than he's going, realistically.
Except for with the multiverse.
Except for with the multiverse.
Because
And
if
of
you
course,
have
with the
two-
multiverse, you can get 10 to the 10 to the 123 if you like.
Well, with
See,
the multiverse,
that's-
just assuming 2 universes, not multiple universes, you just have 10 to the 21st twice.
That's right, that's right. If you have 10 universes, now you're talking about 10 to the 22nd. So you need not just 10 universes, you need gazillions of universes.
I was just going to point out random changes can run both directions, for and against life also. So if you're going to introduce randomness, you got to take both sides of the picture into account.
You're just making the calculations worse. But you see, with many worlds, anything that can happen has happened. And so the statistics don't matter at that point. Anyway, next week we're going to see how people can look at these numbers and still insist that there cannot be a God. It's called prior probability. And we're going to see it in their own words.